We are now in our final week of remote learning for the school year. So this will be your last tracker and last week of assignments for the entirety of seventh grade. So that should be pretty exciting for, I'm sure, a majority of you guys. Today we are going to go over something called comparing populations, and you will have a quiz is assignment today based on that. As you can see over here, due this week or on your tracker, you're not going to have any assignment on Friday because your official last day of school is actually on Thursday, and that's going to be when our closing ceremony is as well. So make sure you're working to attend that. On Thursday, all I'm asking you to do is imagine math for that day, but there's also going to be an Ed Puzzle video. Just laying out some information for the summer as well with Imagine Math. With that said, let's get started on this lesson. And the lesson's actually going to start with a video.
How can you use dot plots to draw inferences and compare data sets? Think about this question during the lesson. Quinn collects data from a random sample of 20 7th grade students who participate in a youth fitness program. She compares the number of curl-ups each student completed in 30 seconds last year and this year. What can Quinn infer from her comparison of the data sets? Begin by displaying the two data sets in dot plots. Last year's data and this year's. Why are dot plots an appropriate representation for the data sets?
Before we analyze that question, a curl up is essentially the same thing as a sit up. You could see that from the images, but I just want to be clear with that. Now, what dot plots allow you to do, and we use dot plots a lot in 6th grade, is it allows you to get a visual representation of each data point. It allows you to really quickly notice trends and patterns that a traditional table doesn't really allow you to do.
Dot plots show the distribution or shape of the data, and they suggest the center of the data and ways to measure the center. Now, let's use the dot plots to compare the two data sets. Last year's data has a mode of 24 and a range of 7. This year's data has a mode of 28 and a range of 9. When were the students, on average, able to complete more curl-ups? Select your answer.
In addition to what I mentioned earlier about the benefits of a dot plot, the dot plot very easily allows you to identify things like mode, because you're just looking for the basically tallest stack of dots, right? And you can find the range very easily, because all you would do is subtract the dot that's furthest from the right and take away the dot that's furthest to the left, because that gets the biggest minus smallest. Dot plots can also allow you to find the median pretty easily, because you just cross off a dot from each side until you get in the middle. So dot plots also have those advantages. It doesn't really help in terms of finding the mean. You can still find it, but it doesn't make the mean particularly easier. Now, in terms of this question, it says on average, which is asking about the mean. Remember, mean and average are the same thing. You can look at this and say which year on average, right? You can't quickly, I'll say, calculate the average, but you can look at it and say which one looks like there's more curl-ups, and it's definitely this year. Because you can see the shape of the distribution, or where the dots line up, they're further to the right? They're lying on the larger numbers. So that's basically telling me my mean or my average is going to be a little greater on this year compared to where it was last year.
The number of curl-ups completed this year is generally greater than last year. But based on the shape of the data, not all students made the same progress. Quinn can infer from her comparison that the majority of her classmates were able to do more curl-ups this year than they were able to do last year.
Now, one point of reference before we transition back to our notebook slides. This does not mean that all of her classmates did more curl-ups or sit-ups than last year, right? You don't know. Maybe this person who did 21 actually did 24 before. We are just talking about on average what is happening, okay? We can't infer about every student, but we can say most students. So that's an important distinction that you will see on today's Quizizz assignment. You're making inferences or predictions, but you can't assign that it's 100% truth. We're going to take a deeper dive into Quinn's example here, dealing with curl-ups or sit-ups. We have the dot plot down here to the right. Now I'm going to read through this question. You'll be introduced to a little bit of new vocabulary. Quinn computes the mean and the mean absolute deviation, or MAD, for each data set. Now, mean is average. We've already gone over that. I'll explain how to calculate it from a dot plot in a second. Mean absolute deviation, I'm not going to go into detail in terms of how to calculate that, but understand it's a measure of variability or spread of the data. So it's in the same kind of category as range and interquartile range. So the smaller the number, the smaller the MAD, the more clumped up your data points are. So the more consistent your data points are, the closer your MAD is to 0. The larger your MAD is, the more spread out you're going to have. So notice our MAD is greater for this year's because our data is more spread out, okay? Our MAD is smaller or lesser for last year because the data points are more consistent. They're more clumped. Now, if you want to know how to calculate MAD, you can obviously look that up. You can contact me and we can go through that, but it requires its own lesson, but it's basically how far each value is from the average. And then you take the average of that. But just know as a whole that MAD measures spread of data or variability of data. The lower the number, the less variability or spread. Okay? Now, how do these measures, so he calculated the mean and the MAD, support Quinn's inference from the data? Well, we had inferred along with Quinn, I'll say, that on average, right, this year, we had more curl-ups, and that is supported. Now, how did he get these numbers? Well, basically, each of these dots stands for a data point. So having one dot over 20 means you have 20 once. 2 data points over 21 means you have 21 twice. So on and so forth. So you would add all of them up, keeping in mind if there's 2 21s, you have to add 21 twice, or, right, 21 times 2 and make sure you add that on. But you would add all these together, and then you would divide by the number of dots. That's how you get the mean. It's really not too complicated. It's just you understanding that each dot represents one of those numbers at that data point. So having 1, 2, 3, 4, 5 of these dots at 24 means you need 24 5 times. Each dot is its own individual data point. So we know the mode here is 24. We already discussed that. The mode here is 28. But now we know the mean, or on average, right? The curl-ups completed this year is indeed greater because Quinn went through the trouble of calculating that for us. And we've already discussed what the MAD is. So the mean number of curl-ups completed this year is greater than the mean number of curl-ups completed last year, which supported Quinn's initial inference along with our initial inference. Now, the MAD is greater for the number of curl-ups completed this year. Now, this suggests that not all students made the same progress because there's a greater amount of spread, right? There's more variability. So it's not as predictive. The higher the MAD, the more spread there is there. Now, let's look at one more dealing with push-ups now. And I just want you to look at the dot plot because you should immediately be able, within 5 seconds by looking at this, making some inferences. Now, immediately what I'm seeing is last year, people seem to be able to do more push-ups, right? The dots are flowing way more to the right than down here. We have a higher maximum, right? No one got past 9 last year, but this year we have a 10 here, a bunch of 11s, and a bunch of 12s. The mode's actually 11 here, when the mode the previous year was 0 and 1. So on average, I'm going to say that last year seems to have more. And that's before even calculating it. Obviously, if I wanted to explain or prove my reasoning, which it asked me to do here, what I would explain that, oh, the mode's higher here. The data spread shows it shifted further to the right, which means it's greater. But I would go that extra step and actually calculate the mean for last year and the mean for this year and then compare, because that's additional proof showing on average there were more push-ups last year than this year. So, sum this up. There are more dots for greater numbers of push-ups completed last year. Based on the shape of the data, students generally did more push-ups last year than this year. Now, with that information, Yolanda can infer that more of her classmates were able to do more push-ups last year. Once again, notice this statement does not say every student or with 100% certainty. Remember, you're making an inference, which is an educated guess. It doesn't mean it's 100% right. Does not mean everyone could do more last year. Maybe the person who had 9 this year only did 5 last year, right? But on average, more people could do more last year than this year. Just keep that in mind when you're making an inference. Just some key points here. We can use dot plots to make informal comparative inferences about 2 or more populations. Dot plots really allow us to see shape, which is great as we see with data sets A and B. I see the middle of data set A tends to be lower than the middle or spread of data set B. The mode of data set A is 15 and 16, where the range is 10. Remember, range is biggest value minus smallest value. And you can see the values here with the mode of 18 and 19 and the range being 11. Now, remember, MAD measures spread like range does. It's a different metric to measure variability. Okay, the lower the MAD, the more clumped up the data is. As you can see here, data set A is more clumped. Therefore, the MAD here is a little bit lower than data set B, which kind of has this long tail to the side, which means it's more spread out. Okay, remember to calculate mean. Consider each dot an individual data point. You'll add them and divide by the number of dots. Now, you should be prepped for today's Quizizz assignment. So you can hop over there and take that now. If you run into any roadblocks, please reach out with questions.